So actually, it was looking in the form x dy by dt minus y dx by dt. So I thought it was something to do with x by y, and then we would have to differentiate. So I was trying to
No,
figure
actually, I realized from here actually.
Okay.
So this was central force, right?
Mm-hmm.
And this force is always towards the origin.
Yeah.
If you hear the force is here, no matter what, right?
Yes.
Because the force is always towards origin. So about this point, the net torque is zero, right?
Yes.
So the angular momentum is conserved. That's why I did that. Okay. Next question is 13, right? What is 13? 13 or the above one? Which one?
Sir, the 13th one, that is the figure for the question. The two circles.
That is figure for the C and D is figure for? Where is figure? Where is figure?
The next pick I've sent.
Okay, this one, the two disc, right?
Ha.
Okay. So a flat surface of a thing. So you all attempted all the mechanics question?
Yes, sir.
So how many were you able to do it? Like how many percent? 50, 60, 70?
Sir, I have 2015 and 17 years left.
And rest you did?
Yes, sir.
Yes. How many you did?
Sir, I did up till 2014.
So
1970, 44 years basically.
okay, you're doing from 1970.
And I like 44 is starting, I guess, from 77.
Okay. All right.
Because after 2015 to 2022, I'm going to write them as papers.
Okay.
So it's better I don't do right now, right?
Yeah. And thus?
Sir,
Sir, I've also sent you some doubts in the group actually.
Yeah, group change. Okay. So let's see the question. A flat surface of a thin uniform disk A of radius R is glued to the horizontal table. Okay. And another thin uniform disk of mass B M and same goes. Okay. So it is saying that we have one disk and another is doing the pure rolling around the disk, right? In a horizontal plane.
Yes.
The first disk is fixed. This is fixed, right? And only this is moving, right? So a flat surface of a thin disk, okay. Center mass of D has a fixed angular omega about a vertical axis. Okay, so about this axis, the B will have omega. So what is the velocity of B? Omega toward? Okay.
Yes.
Which means the omega of this disk about its own axis for pure rolling condition must be omega dash r equals to 2 omega, VCM equals to omega, right?
Yes.
So VCM we know from the given information, correct?
Yes.
So we can get the omega dash, no? Which is twice the omega of the given value. So the angular momentum, how we write angular momentum? So LA equals to how much? ICM omega dash, because it's omega, plus MVR correct?
Yes.
ICM is AMI square by 2, omega dash is 2 omega plus M, VCM is 2 omega R into 2R. Right? M omega R square plus. Is it 5?
Yes, it is 5. Okay.
Interesting question. Right?
Yes.
So if you remember the circular motion, I defined what is the angular speed of a point. So angular speed of a point we define only in the reference of another point, right? And how we define? By joining the line between them, and we check how at what rate the line is turning. So good use of that concept. Okay. I hope this is clear to all of you.
Yeah.
Very nice question, I would say. Very nice and simple question. Elegant. What is next question? The screen one.
Yes, sir. It is from KTG.
It's from first law of thermodynamics.
Huh.
2015 question, right?
Yes.
Very, very famous question. Slightly lengthy in calculation, but not difficult. Okay, so we have a Now read the question. What is the initial pressure?
P1.
And what is the
Temperature is T1. Volume is V1.
and the spring elongation in the beginning?
It is at the relaxed state.
So is it possible to have pressure P1 from this side and no force from this side and shift the piston at rest? So answer is no. So the problem is with this question, we need to understand that there is this wall is porous wall. So actually atmosphere will come here and will balance. So here P ATM we can call as P1. So the outside pressure is also P1, which is not obvious at first go. Okay.
Okay.
So do I need to read the entire thing? What is the question? So when you heat up to the pressure P2, says that piston gets displaced by what value?
X.
So in a way you have compressed the atmosphere by what value? X only. By what volume? A dx? AX. Obviously.
AX.
So how much energy you need to give to the atmosphere? And how much energy we need to give to the stream? So this must be the work done by gas.
Yes.
Okay. Okay. And the new pressure is how much? The new pressure is P2, right? Volume V2 and temperature T2. Am I right? So now if you write the condition of equilibrium, P1 will A1x will apply, and here it is P2A. Am I right? At a new equilibrium.
Yes.
So P2A is how much? P2 minus P1 into A is Kx. I mean, just you have to create a set of equations and apply the P1 V1 equals to nRT. So P1 V1 by T1 because mode is conserved. Because we have no idea which process it is, right? Now go to option one by one. What is the energy if V2 is 2V1? So by putting V2 equals 2V1, and if you put V2 and T2, you will get the new pressure, right? In terms of old values, correct? Correct.
Yes. Yes.
And once you do so, once you get P2, you can substitute here and you get X or maybe Kx, which you can write as to get the energy stored in this stream, correct? Half Kx by which you can also write as Kx will square by 2K. Understood?
Yes.
So you have to write this way everything. So go through each option, get the new P2, put it here, and substitute. Something should be given. How to get K? Maybe K gets cancelled out. Actually, it's very slow, no? Yeah, we can add this answer. Work done, I guess, is easy to find. This is the sum, of course. And I know what you can say. The P2, this is correct. This we have done. How to get this X done? Okay. Just okay. To convert this dimension. V2 is 2, V1, P1, V1. Something is missing. Just a minute, P1. What is P1? So P2 is how much? 3 by 2 P2, right? Okay, okay. X is given to us. What is X here? Yeah, that's easy one. So we can also write X as V2 minus V1 is how much? AX only, na? Understood.
Yes.
So basically, we'll just X is this is coming. Yeah, fine. You can use the formula now. Because now we can replace here. Right? So energy storage is how much? Half K X square. What is X? Oh, that's nice. And this is the answer, right? Okay.
Yes. Okay.
This is the energy stored. No? Now I can keep on substituting, right? So what is the energy stored in the first case? So we got P2. P2 minus P1 is how much? P1 by 2. And V2 minus V1 is V1, right? So this is the right answer. Just substitution. Okay. Just a manipulation of values. Because K is not given. So we have to think about K. The rest you can do.
Yes, I'll do.
So just repeat the process. You'll get all answers. Anyone having any doubt in this? Tell me. Hello.
No
No.
doubt, sir.
Next is, what is the next question? I don't see any. No, that's it. So your doubts done, Mugdha?
Yes, sir. If anything more is there, I'll see.
Okay. No problem. So just now your question. So the particle starts moving in x plane with a constant tangential acceleration at is 4. And x y plane. At is constant, right?
Yes, sir.
So definitely the path is not circular because the AN is changing. Okay, we'll see what we can. So when you cover the distance, because the AT will decide the distance cover, right? So we can add S equals to UT plus half UT square.
No, S is not displacement, it's distance they are saying.
Yeah, this is distance only. If it is always tangential, what we get is distance only.
Oh,
It's called curvilinear motion, right?
yes.
So for you, it's a straight line. You can stretch it. Because when you are here, the acceleration is this way.
Okay,
this way,
so by
here-
that they only mean displacement, right? 4 meters what they are saying.
Yeah.
Because I was confused with this.
98 marks से 15,000 रैंक आ रही है.
Oh, okay, quite, you can mute yourself. Tanishi. Okay,
120.
Tanishi, you can mute yourself. Okay. So I think part 2 start point. U is 0, right?
Mhm. Yes.
Then I think it is easy one, right? Easy.
But what about the acceleration given in normal?
It will only change the direction.
But
Normal means
when it applies like its distance,
tangential, it is always tangential. No? So
understand?
this formula is like when you are here, A is here, like this. So for you, it's like always supporting, no? Okay. V tangential by ds equals to 4. Okay. So the tangential velocity at any single how much? Like that tangential is V only. So we can do that here also. So the question is okay, because we got the t value. The total accessing how much? And total and normal will be 2 to 4. How much? 18.
√5.
Yeah, that's the right answer.
Understood.
The radius of curvature that you can do always. So how to find the radius of curvature?
We can find velocity over there, right? V square.
That's it.
Yes.
You can use the V from here on.
It is per by
Yeah. Actually, I was confused between distance and displacement. So I thought it would be better to leave the question.
No. In a curvy linear motion, you can always apply the formula because you are using the tangential acceleration. So you can, it's like for you, you have walked on a straight path which you have curved later. Okay, next is next cloud.
Next one is not from mechanics, actually. It's different.
Usually electrostatics.
Actually, it was in IIT-JEE.
No problem. You can solve it. 2 point charges each of charge Q are moving towards the center O of an earth. So the earthing is what? The charge on the sphere must be?
potential of the sphere must be 0.
Yeah, potential of the sphere must be 0, not charge. So these two charges may have their own potential and some negative charge will appear to make the net potential 0, right?
Yes.
So this Q, and some minus Q plus, just assume Q. Sorry, Q dash or some other value can assume. So what happens? The potential of the sphere will be how much? So we can choose this point because at this point it's easy to find. Because the induced charge will be equidistant from the O, right? Whether it's plus or minus, we don't know. So whatever is the charge on the sphere, from center it is equidistant, correct?
Yes, sir.
And therefore we can write the potential formula for O point easily, conveniently. But because it's a conductor, so the moment you find the potential at one point, it will be same for all points, right? So the entire volume of conductor is equipotential. So KQ 1 by R1 plus 1 by R2 plus AQ by capital R must equal to 0, right? Correct?
Yes, sir.
So what is the question actually? Oh, that's easy only. You can solve this easily. So Q just Q into 1 by R1 1 by R2 plus Q dash the R should 0. K gets cancelled, right? So it is minus R 1 by R1 1 by R2 into Q. Can you find this formula? Yes. So what is R1? R2.
Yes.
So 1 by 2 plus 1 by 4 is
That's
minus 3 by 4.
minus 3 by 4. Q.
But this is the right answer, no?
A option.
The next part, okay, if A is if A is right, then B must be wrong. Okay. Yes or no?
Yes.
Now when current, yeah. So for current, what we can do? We can differentiate both sides.
Yes.
The rate at which charge will change on the surface of conductor will be the current, because if it is going, then it will change. Minus RQ is constant. dR1 by dt into 1 by R1 is correct. No, sorry. We are different time only, no? So dR1, yeah, this is R1 is square. Correct? By relation plus. What is dR1 by dt?
B.
Minus V, right? Because R is shrinking, no? And what is dR2 by dt? Minus 2V, right? Okay. So they're asking the value only on magnitude, but anyway, we cannot like this. So, let's substitute the value. V into 1 by R1 square. How much? 4R square.
16.
3 by 8, no?
Yes, sir.
Am I right? Dash.
Yes, just a second. I
Yes,
think so.
sir.
Yes. Huh.
So C is matching, no? Option C, correct? You can check. You can check. Tell me the answer. What is the answer? A and C, no? Okay. Anyway, you can check. You have answer? Yes.
Actually, the answer key I have to check it. I think Parvan Dash has the answer key.
Yes,
That's
sir. It's A and C. It's correct.
That's for the next question.
Yeah,
Next.
this was in numerical.
I can't see the diagram. You have taken half diagram, right?
Diagram, just a second. Wait, I'll send diagram.
This was in which exam? AITS.
AITS.
Sir, open test. I shared you the paper.
Okay. I didn't see it.
Sir, I have a lot of doubts in those papers.
Only through doubt you can learn the concept. Now you know how to solve this question. Right?
I was only able to attempt 4 or 5 in each paper out of 18.
Okay, really bad.
I attempted 11.
Okay. Next. Just a second. Or should we do the mechanics first? Like I can keep on doing all this. Current is also okay. This is fine. Okay. In the circuit shown, I hope this is the question, right? All values are written. Okay. So in the circuit shown initially, the capacitor C1 is this. Potential is given for V1. How much? 4 volt. And for V2? 6 volt, which means now we don't know we have a charge here. So some charge here, we can just do the charge. And I think polarity is given. Yeah. So we can find the charge here. Q1, V2. Q1 is CV, right? And Q2 is like this. So far, so good. Yeah. Okay, Shannon, one. Okay, let me solve it. So eventually, what will happen? All charge will, because there is no source of energy. So all charge will flow in a way to balance the potential. So what will happen? Eventually, the charge flow will stop. Yes or no?
Yes.
So what will be the final configuration of charge? So it will look like this. The C1, C2 becomes. So this will short circuit, right? If there is no flow of charge from here, what is the potential drop across the C2? Zero only, no? In the steady state, what will happen? Tell me. In the steady state, you know the answer. What happens? The current flow will stop. Okay, Per, you stop sending now. Okay, because I'm reading the question, it's coming as a notification.
Okay.
So, in the steady state, the flow of current will stop. So it is just like a. So in a way, all are short circuited, like you can see. So this capacitor is also short circuit, and this is also short circuit. So all charge will vanish. That's the first step of solving this question. So what is the total energy stored in the system? Half C1 V1 square plus half C2 V2 and all of the energy has gone. So the question is, but what they're asking is, how much energy will go from the 3 ohm? No, 3 kilo ohm, right? This is a pathfinder question, simple. Yeah. So the long process is you have to solve it. And the short is some sort of intuition. Intuition says this charge is there. I will find the question. So imagine there's a ghost cell. What do we have? A ghost cell of 0 potential. So you can draw like this. And now this ghost cell will come here and will deposit some charge on the C1. So it's the initial charge plus the new charge. Let's call it Q1. But I should say this as Q1 plus some value. Let's call Q. And here it will be Q2 plus Q dash because it's not the same. There are many equations that I need to write here, which I will write in a and this should be solved logically by some trick as far as I remember. Right, KVL. So for this circuit, you can write I2 R2 must equal to this is the question. And this you can say Q double dash. Just to make sure that the Q gets the so Q is Q dash plus Q double dash. I2 is dq double dash by dt. And then I1 or I is dq by dt. So these are the set of questions we get in the circuit. And then we practice entire KVL math from here, or you can actually this. Review minus IR1 minus n plus 3 by C1 minus I2 R2 equals to 0. And what we are supposed to do is we are supposed to write the equation only in I2 and R2. So we need I2 and Q double dash in the last equation. The rest we don't need. Do you get some insight from here? There's so many questions to solve. Okay, I'll solve this because it will take a lot of time actually. to solve it. Next. The next question is again easy only. If you look carefully, what is this? Xi plus YG upon R cube, correct? Hello, hello.
Yes.
If the force is always radial, if the force is always radial, so in a circular orbit, the direction of force and displacement will be always mutually perpendicular. And you are moving this way. What is the force and displacement? So, what is the question? Work is 0, right? Hello, hello, hello. It is clear?
Yes, sir.
Okay. I hope this is clear. Next. Any question before this? We
Yes,
have done
sir.
all right. The next is what is this? A charge given in Is it having some other part? Varun?
Oh, sir, that's it.
So there is no magnetic field.
Yes, sir, no magnetic.
No, magnetic field will be developed by the moving charge only. It is like current. And the field will create a field. You can find the field only at the center. Not anywhere else. And if you talk about the torque briefly, VM crossing. If there is no magnetic field, then why it is required?
That's what like what to how to use that charge.
Charge will rotate. As the block will descend, the charge will rotate, right?
Okay.
So after you have descended, so what they're asking is, the moment you release from rest, it will have only alpha but no omega, right?
Sir, actually, they have given a relation between charge and mass, if you've seen that brackets.
Yeah. Thank you, that. Is it part of some? No, is it in comprehension? Or this is the one?
No, sir,
Okay.
like not the question. Multiple current.
Charge creates a current creates a field. And how to use the field if it is possible? Okay. Got it. No. Okay. There's a number of turns of okay. Or insulting. Okay, fine. But something like this. The current will be Q omega by 2 pi, right?
Yes, sir.
So di by dt will be d omega by dt, which is alpha, right?
Yes.
And will it have the, it's the solenoid now because it is a cylinder. So the L of solenoid is how much? So we find the L of a solenoid, like a hollow cylinder. So if you look at the flux, okay, you have to treat as an infinite solenoid. So flux will be equal to B into H pi alpha. B we can think as not
Anyway.
I by L, right? This one we study, right? For the uniformly charged cylinder, right?
Oh, yes.
So, What is given the value? Anything is given, no?
Yes, sir. So that mu naught q square by 4 pi L is small m. So it becomes mr square.
Alpha is also, sorry. Alpha is right. Okay. So it is mr square. Yeah, so far so good. So as alpha will increase, it will create a counterclockwise torque actually. So what will happen? Tension will support, and then this torque will oppose. So the net torque on a cylinder is how much? T minus TR minus tau is ICM alpha. So TR minus tau. ICM is SL cylinder. And alpha is AC, right? And then GY4 is answer. Can you check?
Yeah, sir. Just yes, sir. It's GY4.
So there are many, I would say, mistake in the question. I solved with the issue that, okay, first of all, this question is only true if L is infinitely large compared to radius. So if L is much bigger than R, then we can solve. Then only we can think as a solenoid. Okay. So I did a lot of things, and you can think so much. Okay.
There is a, like, we used Faraday's law, right, to find the
Yeah.
EMF.
Yeah, what I did was the changing magnetic field induced the electric field. So I used the time variable magnetic field in a cylindrical region, if you remember. Just I hope you don't remember this. So we had a question like this: if we have a cylindrical magnetic field like this, and if the dE by dt is changing, so it will induce the electric field. Right? At a distance r, what is the electric field? So we write E into 2 pi r, which is the EMF,
OR by 3 epsilon.
is equals to pi r square dE by dt. This is from the right is Faraday law, and this is the electric field. So we are trying to find near the boundary only because the charge is here only. So anyway, E becomes r by 2 dE by dt. And a rotating cylinder, if you again go back to the magnesium chapter, I have derived this formula. For rotating cylinder, it will create the B inside, right? Only if it is like solenoid. And this B will be mu naught I by M, if you remember. This we have derived, okay. And because as the cylinder will rotate, the B will change. And so E will induce. And once E is there, E will be tangential to the charge. Therefore, the force will be QE tangential. So the torque will be QER. So I did a lot of things actually. You can spend some time to realize whatever it is.
Okay.
Okay. Sir.
This is complete electromagnetic. Question number 11. A particle of mass m equals to 0.1 kg. So particle of mass 0.1 kg moving vertically downward. Okay. Velocity of kg. So it must move with right v, right? And velocity along the common normal must be same. Correct?
Yes, sir.
Okay. So the first question is. Oh, this is different question. Sorry.
Sir, actually, impulsive friction.
No, it's a collision question, right?
Yes.
Yeah, impulsive normal will come in anyway. So if you do the impulse diagram for each body separately, the impulse on this hemisphere will act like this, and the same impulse on the ball will act opposite.
Yes.
And E is given. So what is the component here? This is how much? U cos 53, right?
Yeah.
So this component will remain unchanged, which is, and this will let's change to some.
So but that's friction also acting on it.
Pardon?
That's friction also at the collision point.
Oh,
So there's friction everywhere, even on the hemisphere. There's friction acting on the ground the moment it collides.
very good. No problem. So it will experience this J will have two components. Jx and the value of Jx is how much? J cos 27, am I right? And the J vertical is how much? J sin 37, correct?
Yeah.
So this will be mu J sin 37. Okay? Because this J will balance the vertical J, correct? Basically, what I'm trying to write is mu Jn, which I write as mu J sin 37. It is clear so far? And we have different mu, right?
Sir,
Yeah.
there is a tangential friction acting at that point. Then the normal will also balance the component of the tangential friction acting on the hemisphere. No?
That is applied now. So for the okay. You are saying I mean, actually, I missed this part.
Yeah.
Now I was going to, yeah, then it will change slightly. So this will also have common like a horizontal and vertical, right?
Yes.
And we need to find this angle. How much is the angle? 53. Correct?
Yes, sir. 53.
Yeah.
Or too many components. Anything. This is correct. Right? So for the wedge, the horizontal impulse is how much? J cos 37 minus mu dash J mu dash J how much? Cos
53.
these are the two horizontal, right? Equals to M. So far so good. And what is Jn now?
Sir, mu J also in the first equation.
Pardon?
The
Will mu
friction
J
between hemisphere and the ground.
in the first horizontal equation.
Ah. My bad. And then Jn how much? It will balance it. Jn sin 37 plus
Mu dash J sin 53.
And for ball, M U sin 53 minus in the last question is theta. So velocity of separation is how much? And the velocity of approaches. If this is the equation, can you count the equation variable? Are we equal with the equation variable? Yes, we should.
Yes, sir.
Okay, rest I will not solve, as you know. You can solve rest.
Sir, we actually can't use the momentum conservation because of impulsive friction and all.
Friction,
Right?
yeah, correct. This is the only question of impulse momentum, and this must be Federici question, right?
Yes, sir.
So
Only Federici guys can do this. I know who must be doing all this. Anyway, so this is definitely this much will not come in J advance for sure. So, but this is good for solving. Right? Maybe if those who are going to get the rank 1 and 2, it is for those guys actually. So they do all this thing because they have to solve every question anyway. But to get into IIT, nothing of this difficulty is required. So IIT may use a part of it, not making everything so complex. Okay. Next.
sir, the
Yes.
V separation where you took along which line? I didn't understand.
Along the common normal.
Okay.
So this velocity V is like this for the wedge, right? So I took this one.
Okay.
Not difficult, but you have to write a lot of things. Okay? So keeping track of everything in a nice way is important. Okay. The capsita question is from the Pathfinder, which is very difficult, not easy. Let me see that question. I can tell you what I did that question. So I solved in 2019. There was some capacitor, so electrostatics. Current and electricity. Yeah, same question. So that was a question which I solved by some hook and crook. I remember the question. This is the question, the last question of Pathfinder. Build your understanding. So it is difficult, of course. Same values you can see. JEE level question, it's not difficult. In fact, I have circled this question. Something was prolonged this question. Maybe G will ask only Pathfinder. What is the purpose of asking Pathfinder? Okay, next. Same question you can see, right?
Yes, sir.
So just change the value, right?
Yeah.
The next is also Pathfinder, right? All are Pathfinder question. Anyway, this question is Pathfinder question. Not difficult.
Copied from past.
Yeah, that's not required. I'll just tell you which question not to solve anyway. Wasting time is of no use. Okay, we can solve the third question. That's easy only.
Third question is we did in the class only, no?
Yeah, yeah, of course. Why are you asking this question?
Actually, I also remember the answer. It's somewhat similar.
It is like
ABD is the answer.
under root will come, some under root 2 will come.
We did a mistake over there. Then you thought that there will be two normal forces, right? One
Yes.
mg m omega square r and another from that side also.
N will be balancing gravity and N will be giving you the tension.
Yeah.
But there is no friction here, no? This is even easier question.
Yeah, without friction actually.
No, this is a question on conservation of angular momentum actually. It's a different, slightly different. In fact, I have told this question how to solve if the omega is given and it is released from rest. So as it will go away, omega will decrease, right?
Yes, we can use I omega over here.
Yeah,
Initially,
that
I
will-
omega will be ml square by 3.
Correct.
But after that, it will become ml square by 3 plus a mass of ring into length square.
Correct. Let me solve this. It's a nice one. Or you guys can try. Just you can try.
What?
Try this question.
No, actually done. This is AITS paper only.
Yeah.
I got correct this one.
Okay, good.
ABD.
So you can go to the next question then.
Sir, I'll try it once again.
This screen question again says so many screen and log there. Again of no use, but anyway. The next is completely Pathfinder. Okay, I will send you a solution directly. Okay, the next one. This you can probably do with the center mass ring. The 15th question.
I wanted to try, but like I didn't understand the rotational का कैसे. I will like how to add rotational into.
You know, at the diametrically opposite point, your horizontal velocity will be same as the that of the this
Yeah,
what is it?
VC.
VC. And what else you can do? And then you can conserve the angular momentum about the bottom actually. Because external force is friction and normal, right? And both the external force will pass to the bottom only. So angular momentum is conserved about the bottom for the system. And in the beginning it is zero only. Correct? Because about bottom M V not R is zero because R is nothing. And when you are at this point, so इसमें हम लोग का mass M is initially the lowest content. So mass is same, so I can do. So if you are able to just reach there, I think system will come to rest only, right? No, momentum we should conserve. Wait. Momentum to conserve the
VCM.
yeah, momentum to conserve. This must have V, and because there is no friction, so this will also have the V like this,
VC.
right?
Yeah.
And then we can say it will come V naught by 2, right? By logic. Conservation momentum.
Yeah.
So now what is the angular momentum about the bottom? Is it required? Yes, purely no omega. But angular momentum should be 0, right? So the block should not have the rotating direction upward direction. If you assume that both the hoop and the mass come to rest, then it will violate the momentum conservation. For sure. If it is able to reach only that much point, how is it possible?
So MGH plus half I omega square.
The block will come to rest actually, completely. And
With respect to the ring or in ground side?
but angular momentum is 0.
Sir, but block isn't rotating. No? Block will just be moving forward with VC. Or will it also rotate?
No, I just going to see that.
The CM frame.
Then in CM frame, we will have some, this is the initial energy. In the
Huh.
final energy will be, that is same. Just a minute, I think. This is a good question. A small block. Some. Okay. The first mistake is here only. We can't consider the momentum because we have friction. So only we can consider is angular momentum. So the angular momentum is 0 in the beginning, right? About what one?
Yes.
Uh, we can't conserve the angular momentum because gravity is not acting here. So when the block is here, the mg of the center mass will be somewhere here, right? And this will do not let you conserve the angular momentum also because it will create a torque, right? Okay, now I got the question. Not full. Just so definitely what we can conserve is energy. Let me think in terms of energy. Can we get the answer? So center mass will always move in a circle of radius half, correct? Albert, the mass is same, right? So when the block will be almost here, the center mass of the system will go from here to here. Hmm. I need to think about this. Not it. Can we conserve the angular momentum on a system? The answer is no. About bottom, there's a friction. Will be there because of gravity. Can we conserve the energy? The answer is yes. Okay, only let's conserve the energy. What is the initial energy? Half m. Because we are not supposed to conserve the momentum also because we have external force. So half m will destroy the energy and the final energy will be how much? mgh. Plus maybe some kinetic energy of the system. And this is what we have to think. In the R. Energy relation this. And now Configuration of system. The only thing we conserve is energy only, nothing else. Right. What is the answer given for this question? 15 number. Darsh.
Yes, sir, just one second. It's given 3 meters.
3 meter per second.
Yeah. Under root 3 GR they've got. V naught is equal to under root 3 GR.
So here the energy, apart from energy, what we have conserved? Do you have the solution?
Yes, sir. Should I share?
Yeah. Just share. And share for the 14 also.
Okay.
I mean, first one. Good. Because they have solved separately. I mean, of course, they haven't shown how they have solved, but that's a big step. So first they got the voltage across each capacitor as a function of time t, right? This is V1, which is voltage, right? And then they use the formula. Yeah, and this is not complete solution. It's only half solution. The biggest part they haven't shown here. Anyway. Okay, this I got this. This is not interesting. So they have used the impulse momentum theorem here as well.
Both linear and angular they use.
Yeah. So for the system, they have written the for system line impulse momentum theorem. So for system, what is the initial momentum? MV naught. At the
Yeah.
maximum point, they have taken the same velocity for the block to the center mass. So the initial momentum minus impulse of friction equals to the final momentum, which is 2 right? Yes. Okay, so this is the first step. So mv naught minus fsdt is the first step. And the same friction will create the omega, right? So the torque of fs is how much? Fs are dt. Okay. Fs are dt will be how much? So in the beginning you had nothing. System is having no omega, right?
Yeah.
It will make it ICM. What is the main definition about the system? About synchronous.
So only the ring is rotating, no? So we won't have to
Yeah,
consider
yeah. So we can this we applied only for ring actually.
because the block won't have any like rotational component.
Yes.
But
We can simulate the MR square to omega only. And then you can substitute. Sorry, you can. So from 1 and 2 that minus n r omega is v. And r omega is v, right? For the I mean pure omega, right? MV not is 3 MV. Correct?
yes,
The V is V not. Now at the conservation of energy. Half V0 square plus equal to GR plus the energy of the ring will be half 2n square into omega square, which is V0 plus half V square, which is V0. So half V0 square, just take the calculation. This is right. 3 by 18. 6 by 6. How much is this? So I hope this is done, right? Hello, hello.
Yes, sir, understood.
So mechanics part is just finished from the J advanced part. Okay. In FIDG, anyway, you will get many question of Pathfinder only. So they ask question of Pathfinder. Sometimes what happens, like it's difficult to expect that they will ask so deep. Sometimes we don't apply so much brain. Sometimes they bring the question which are controversial. But if we're able to solve, let's say 50% of FIDG, that's more than enough. So how many are able to solve?
Sir, 4 to 5 out of 18.
Out of 18, 45 is okay. Oh, good one. Make it 7 to 8.
Yeah, so this was still open test, so they had made it more difficult. I checked the like normal advanced papers; they were much more solvable than this.
No, this
Okay,
is
no.
only to see. FIDG is for those who know everything.
Hmm.
So they just kind of challenge everyone. Like even you know everything, still you can challenge. That's the whole idea. So those who get the top rank, they solve a 50% with 8 questions, 9 questions. Anyway, for solving 2 questions is good enough. But okay, what you could discuss with me, because through that discussion you can get some insight. Okay.
Yeah,
That
so
will,
because mainly impulse momentum, I wanted to learn from these questions.
yeah.
I didn't know how to apply that properly. So here I got that example 2 times.
Yes. Okay, so the next set of chapters that which you should attempt is, I think mechanics is over for all of you.
Yes, sir.
Mudai finish mechanics.
Sir, I'm still doing it. I'll complete it in.
Mudai is gone. Okay. I think Hasika is only left with the 2 years, right? 15, 17. Just mechanics over, right?
Yes.
Almost. Okay. So I think the next set of chapters that I would like to discuss is from
Electrodynamics.
no, let's please learn first because now it's small. Gravitation and fluids. The gravity and fluid that we are going to discuss with on wave and sound. I think that will complete the class 11 syllabus, right? And the properties of matter, right? This will finish everything.
Yes, sir.
After this, the next will be heat and thermodynamics complete. And then we start the optics. So up to here, you will cover almost 60% of syllabus in the advanced part of it. And then we can do the 12th part. So 12th will have electro, EMI, capacitor, and all everything together. So now finish on this part. Gravitation and force. Okay. The next question we didn't solve today. The capacitor one. Yeah, that I haven't solved even before also. I want to check it. So question number is not given. There is spring and a disc question. You can see. Okay. So okay, if you want to discuss, it's an EMI question actually. So connecting disk of mass and volume is suspended with help of light string of constant field fixed support. Oh, fine. You have to think in terms of return flux and all. Okay. So think about it. It's not difficult. These questions are solvable. But this is again from Pathfinder only. Okay. Okay. Any other topic you want to discuss? From mechanics, Josh, Hasika, Varun.
Sir, I don't think any other topics I'm feeling difficulty.
Okay, so rotational, you guys are okay in rotation?
Yes, you just need to practice with
Sir,
that impure
The
coding part.
rotational is still going on.
Okay.
So just impure rolling is a problematic part.
So I think we can do this. See, rotation, you can spend some more time. Don't worry about the other chapter. Rotation will have question for sure in advance, as you know.
Yeah.
Or we'll have minimum 4 questions, maximum can go to 12 also. So this is something that we can't afford to miss. So you can spend some more time with rotation. And let me tell you one thing very clearly. You all have seen that the JEE-Mains physics was very easy, right? So
Yes,
far,
sir.
I will bet the JEE Advanced Physics this year will be the most difficult. So they will play this game for sure, 100%. So you have to be good with physics one, because now you can expect slightly respite on the chemistry and mathematics. But physics will be real good, not very real good. Okay. All right.
Sir, impure rolling is one topic which had a problem
Pardon?
with.
Pardon?
Impure rolling.
Impure rolling.
Huh.
Impure rolling means if the kinetic friction will come. Now that's easy for you because kinetic friction will have fixed formula, mu(n).
Okay.
So the torque will be mu(n) into R. About center mass. And
Yeah.
laws of motion will be like mu(n) equals to minus ma, or if there are some other force, then you can subtract. So
Okay.
the moment it is impure rolling, you're lucky actually. So that will change the friction to a known value. Mu into n you can calculate, right? The n will be
Yeah.
equals to some equilibrium equation. You have to find to get n and solve that.
Okay.
I think conceptually we have discussed almost everything in mechanics.
Yeah.
Yeah, anything, I mean, still left, I think few derivation, remember the basic derivations also, the answers also. And I think practice is the only way you can do something good in advance. So make sure that you do as much practice as possible, and you can bring the best out of you to practice only. So solve more, discuss more, we'll see more ideas in the next lecture, but I'll keep the next lecture slightly earlier. This gravitational fluids, I think, how much time you need to tell me?
One
Gravitation-
lecture is enough, I guess.
No, not one lecture. I'm saying gravitational fluids, wave sound, and PM.
Which
So
is
one
solving
doubt.
time, 2 days.
How much time you guys need?
Yes, sir. 2 days is more than sufficient.
I think we can meet again on Saturday.
Saturday, yes.
Yes, sir. Saturday.
Okay, sir.
Saturday, sir, can you keep lecture late? I mean, around.
Saturday will be late night only, 9 to 12.
That's best.
Is it okay for all of you?
Yes.
Asika, it's okay?
Yes, sir.
Okay, so we'll meet on Saturday now, because now I want to finish quickly. So on Saturday, we'll discuss these topics. Just make sure that you are doing these topics completely and exhaustively. Okay,
Yes.
All
We'll
right.
do.
Yeah.
Awesome.
bye and take care.
Bye. Bye.
Bye, sir. Thank you, sir.